Hello and welcome to the live session by Infinity Learn by Sri Chaitanya. I am Misbah, your maths educator, and in this session we are going to start with congruence of triangles. So we'll see the basics of congruency first, and then we'll be seeing the congruency criteria, and then we'll be doing some questions on the basis of those criteria. So basically you have already studied congruency criteria in grade 7 as well and have done many questions in grade 8 as well, and in 9 basically you're just doing advanced questions on the basis of those concepts only. So let's start with it, guys. So the very first thing over here is, what do we mean by congruency? So two figures having the same shape and size are called congruent figures. Having the same shape as well as same size. Hi math and science, welcome to this session. Hi Owain, I hope I'm pronouncing your name correctly. So the two figures having the same shape and size are known as congruent figures. I mean, they look like each other and they are of the same size as well. Hi Kunal, welcome to this session. So just take an example over here. Although if I take, give me some seconds, although they are not exactly congruent, the laps, right, the palms of our hands, they are of the same shape mostly. I mean, don't take it exactly, you know that the palms will not be exactly same, but still just to understand, if you put one palm on the other, if you see on this from this side, you will not be able to see the palm behind it, and if you see like this, you are not able to see the palm behind it. So basically they are of the same shape as well as same size. They are basically completely overlapping each other. If you are putting something on the other thing, they are completely overlapping or covering each other. So that is the meaning of congruent figures. So if I take examples over here, for example, I take a simple triangle, right? Suppose I'm taking this triangle, and if I take some other triangle over here, I mean, obviously they are not congruent, I'm just making a rough figure. I hope you understand that, right? So if I take this triangle on this triangle, if I'm putting this triangle on the other triangle, and if they completely cover each other from both the sides, it's not just from one side. Hi Kunal, hello Life on Road, hello Abhi, Sita. Basically they are covering up like this. If you see from this side, you'll not be able to see the hand behind it. If you see like this side, you're not able to see the hand behind it. They are exactly covering each other. It means they are of the same shape. It means they look like each other and they are of the same size as well. So that is the meaning of congruent figures. I hope it is clear to every student in this session. So two plane figures are congruent if each one, when superimposed. Superimposed means when put on one another, on the other, covers the other exactly. On one another, it's not just one way. In both the ways, they must cover each other. It means like this as well as like this. Got it? So they must cover each other when you put one on the other. So then you will say that the two figures are congruent to each other. I hope it is clear to every student over here. So two figures of the same shape as well as same size, they are known as congruent figures. So two line segments are congruent if they are of equal lengths. These are examples over here. For example, I take one line segment over here. Suppose this is AB. And if I take another line segment over here, suppose this is CD. So they will be congruent to each other if their lengths are equal. Lengths we will show like this, guys. AB is equal to CD. Because if their lengths are same, if you put this line segment and if you take the first line segment and put on the other line segment, they will completely cover each other. You got it? Or you take this line segment and put on the first one, they will completely cover each other. Hi Rajkumar. So that is the meaning of congruency. Any doubt in these things, guys, just confirm that in the chat. The basics of congruency, that is the basic definition of congruency. I hope it is clear to every student in this session. Okay. Now two angles of equal measures are congruent. Two angles of equal measures. For example, if I take a 60-degree angle over here, suppose it is 60, and you take another angle which is also 60 degrees. So they are congruent to each other. So in case of angles, the length of the arms does not matter. You got that logic or not? The length of the arms does not matter actually in case of angles. Basically, if you take this angle and if you put it over here, so it will cover it up like this exactly. Okay. So the length of the arms does not matter in case of congruency of angles. Basic logic, basic concept, right? Now two circles of the same radii are congruent. So if you make two circles over here Any circle, I'm just making a rough figure. They are not exactly congruent, you understand, because it's just a rough figure. If their radii are same, for example, this is 2 centimeter and the radius of the other circle is also 2. If you put this circle on this one, it will completely cover up this circle, and also if you put this circle on this one, this will completely cover this. They both must cover each other exactly. We have just started, Ankit. I'll explain that as well. Don't bother. I'll give that logic as well. Okay, Ankit? We have just started. First, understand the meaning of congruency. Then I will explain why SSA or ASS is not a congruency criterion. I hope that is clear, Ankit, up till here. Okay. Now, two squares of the same side are congruent. Basically, two regular polygons of equal lengths of sides, they are congruent to each other. Whether they are two equilateral triangles of same length, same side lengths, two squares of same side lengths, two regular hexagons of same side lengths, two regular pentagons of same side lengths, they are congruent to each other because they will completely cover up each other. If you make a square over here and if you take another square, suppose you know that they are not congruent, I'm just making a rough figure, right? So they will completely cover up each other if their lengths of sides are equal. So two regular polygons, whether it is equilateral triangle, square, regular pentagon, regular hexagon, having equal side lengths will be congruent to each other every time. I hope this is clear to you. Now, two rectangles are congruent if they have the same length and same breadth. It's easy to understand if you make two rectangles over here. See, in a rectangle, angles are already equal. Angles are already equal. So, if their lengths are equal and their breadths are also equal, then they will be congruent to each other. Angles are already equal in two rectangles. You know that each angle in a rectangle is a right angle. So, is the basic definition of congruency clear to every student in this session? Just confirm that in the chat, guys. Is the basic definition of congruency clear? Okay. Now, basically, we talk about congruency in case of triangles, right? That is the main purpose of this session. Or up till grade 10 or in any grade, basically you study congruency with respect to triangles most of the times, right? I hope it is okay with you. So, if two triangles ABC and DEF are congruent under the correspondence, you see this word is very important, correspondence. Suppose if I have got two triangles ABC and DEF over here, you see ABC, this word is very important. ABC and okay, that is DEF. So correspondence matters in case of congruency. It means if ABC is congruent to DEF, we write like this, guys, ABC congruent to triangle DEF. Now tell me one thing, can I write like this, guys, ABC congruent to EDF? Can I write like this? Is this statement true or false? Tell me. Is the second mathematical statement true or false? Just confirm that in the chat, guys. Is the second statement true? Can I write like this over here? If ABC is congruent to DEF, can I write ABC congruent to EDF as well over here? Can you tell that, Abhipsita, Shinjini? Okay, that you people are saying that is true. No, that is not true. That's what I was trying to say, that congruence, in case of congruence, correspondence matters. You cannot write names as per your own wish. That will be wrong to say that. If it is given over here that triangle ABC is congruent to DEF, very good, Kunal, that is not true. Shinjini, see, because A is falling on D, B is falling on E, and C is falling on F. If you take this triangle, you can put it over here. So only correspondingly you can write. ABC is congruent to DEF, that is correct. But if you will write EDF, you see A is corresponding to E, B is corresponding to D, and C is corresponding to F. But that is not the actual situation over here. So therefore it is false. But that can happen that you can change the names of both of them. Suppose I am writing BAC congruent to triangle EDF. Can I do like this? Tell me. This statement is true because you are doing changes correspondingly over there. I can write BAC corresponding congruent to EDF. That is correct. I can do corresponding changes in the names of both of those triangles. That is correct. But you cannot write names as per your own wish in case of congruency of triangles. You cannot say that the name of triangle DEF is EDF. That is correct. If you are doing it independently, you are true that triangle DEF can be also said as EDF. That is correct. But when you are writing congruency statement, you have to write the names correspondingly, otherwise it will be wrong. You got that logic, guys? Any doubt in that thing? Just confirm that in the chat. You have to work correspondingly, otherwise it will be wrong. I hope this is clear to every student in this session. Okay, now basically if the triangles are congruent, corresponding parts are equal. We have got ABC congruent to DEF over here. So I can write AB is equal to DE, BC is equal to EF, BC is equal to EF, and AC is equal to DF. Correct? And corresponding angles are also equal. A is equal to D, B is equal to E, B is equal to E, and C is equal to F. And we write in short as CPCT. CPCT means corresponding parts of congruent triangles. So if two triangles are congruent, corresponding parts are equal. You got it? So in both ways it is true. If the corresponding parts of two triangles are equal, then the triangles will be congruent, and the other way around, if two triangles are congruent, then corresponding parts are equal. In both ways it is true. You got that logic? If two triangles are given to be congruent, then corresponding parts of those two triangles, corresponding parts are 6 parts, 3 pairs of sides and 3 pairs of angles, that will be equal. And we write in short as CPCT, corresponding parts of congruent triangles, CPCT. And if in two triangles, 6 pairs of corresponding parts are equal, then the triangles will be congruent. So in both ways it is true. Now the question comes in your mind that if suppose I want to prove two triangles to be congruent, is it compulsory for us to prove all the 6 pairs to be equal every time? Can you tell me what is the answer to this? If I want to prove two triangles to be congruent, is it compulsory for us to prove all these 6 pairs to be equal every time? Tell me, guys. What will you say in this case? If suppose I want to prove two triangles to be congruent, suppose I have got triangle PQR and suppose I have got triangle XYZ, and I want to prove these two triangles to be congruent. So is it compulsory on our part to prove all the 3 pairs of sides and the 3 pairs of angles to be equal every time? Tell me, guys. Yes, correct, Kunal. So the answer to it is no. You don't need to prove all the 6 parts, all the 6 pairs to be equal, that is 3 angles and 3 sides, to be equal to prove two triangles to be congruent. It is not compulsory on your part because there are some rules. For example, the first one is, we'll see them one by one, but first I'm introducing it. There is one rule, SAS congruency criterion. Side, angle, side. It means if in two triangles, 2 sides and the included angle in between them will be equal, then the triangles will be congruent. You don't need to prove other parts to be equal. The other parts will be automatically fixing. You don't need to go to the extent of proving all the 6 parts to be equal. Only this much will do. You got that logic? Only this much will do. But one more thing in this, I have seen many students, they make congruency criterion as per their own wish. That is not true. You cannot make congruency criterion as per your own wish, because there are some fixed congruency criteria which can be used and they can be proved. There is a proof to each of these congruency criterion. Only SAS cannot be proved. SAS congruency criterion cannot be proved because that is an axiom. You understand that? SAS congruency criterion is an axiom. It is not a theorem. There is no mathematical proof to SAS congruency criterion. Yeah, that is another thing that you can practically verify that, but mathematically you'll never be able to prove the SAS congruency criterion. You got that? Because it is an axiom. So there are only fixed congruency criteria which can be used. I will show each of them one by one and we'll be doing questions as well, don't bother. So the first one is SAS, then you have got ASA, and basically AAS also comes in this category only, although there is a difference in the use of these as well. I will explain that. ASA, and then you have got SSS, side, and there is RHS. This is specifically in right angle triangles, right angle, hypotenuse, side. Only these congruency criteria are there. There is no other congruency criterion as per your own wish. You cannot say that YA. I will explain that YAA is not there. One student, I think Ankit, asked that why SSA is not there. I will explain. Or you cannot say ASS. These are not congruency criteria. You cannot cook up congruency criterion as per your own convenience. Only these are the congruency criteria which can be used, because these are proved congruency criteria that can be verified. Basically, you must have seen. I'm not going to do the proof over here, Shinjini. You got that? Because there is a proof to each of these as well. There is a proof to ASA, there is a proof to SSS, there is a proof to RHS as well. I'm not proving it right now. You got that logic? Because we'll be doing questions. And that cannot be proved, Shinjini. That is not proof, that is verification. There is a difference between proof and verification. SAS can never be proved because it's an axiom. You have studied axioms are mathematical statements which we take to be obvious natural truths without any proof. For example, linear pair axiom. For example, corresponding angles axiom. These are axioms which cannot be proved. For example, you can take a simple axiom as well. For example, in mathematics, many a times, I'll show over here, many a times in mathematics you write like this or not, that if A is equal to B and B is equal to C, then you conclude that A is equal to C. You got it? You conclude this or not, that if A is equal to B and B is equal to C, then you will say A is equal to C. This is an axiom. This cannot be proved, but you take it to be obvious natural truth. You got that logic? There are many other axioms in mathematics. You must have studied in the chapter in Euclid's geometry, right, in grade 9. So basically, if A is equal to B, then you say, if you add same thing on both the sides of this equation, A plus C is equal to B plus C. This is also an axiom. This cannot be proved mathematically. You got it? But you take it to be obvious natural truth. I hope this is clear. So in the same manner, SAS congruency axiom is there, but these are theorems. These can be proved, and basically these are proved using SAS congruency axiom only. If triangle ABC and XYZ are congruent by SSS, it cannot be proved, Kunal. That's what I'm saying. That is not the proof of the theorem. Are you agreeing with me, Kunal? That is not the proof. Now you don't need to use logic that much, because it was not done up till now, so you will also not be able to do. That is an axiom, so it cannot be proved. SAS congruency axiom cannot be proved. You got that logic up till here? Okay, I hope it is clear. Now let's see each of these congruency criterion one by one. So the first one is SAS congruency rule, which is an axiom we will not be able to prove. I'll just show this, okay? So basically, if you have got two triangles like this, ABC over here, and if you have got PQR over here, and it is given over here. See, if two sides are given to be equal, this is equal to this and this is equal to this, and the included angle between them. Don't forget that you have to take included angle. So if over here AB is equal to PQ, AB is equal to PQ, BC is equal to QR, and angle B is equal to angle Q. So if two sides and the included angle between those two sides are equal, then you can conclude that the triangles are congruent. Then you can conclude the triangle ABC is congruent to PQR, and you will write in bracket SAS congruency criterion. You got that logic? SAS only you have to write. And obviously if they are congruent, other parts will be equal, other corresponding parts will be equal. It means that if they are congruent, if you have proved them to be congruent, then AC is equal to PR, and then you can say angle A is equal to P, A is equal to P, and over here you can say C is equal to R, and you can write in short CPCT, corresponding parts of congruent triangles. You understood that? SAS means two equal sides and the included angle must be equal. Included angle I am talking about. It means the angle must be in between two equal sides. This angle, if suppose this is equal to this, then you cannot say that the triangles are congruent or not. Is this clear to every student in this session? So that is a basic example of the SAS congruency criterion. Now you can say, you may ask one question that why there is no congruency rule like this, ASS or SSA. You may ask a question that why these are not congruency criterion. Ankit, are you there in this session? You were asking this question. So I'm explaining that thing to you. Give me some seconds. See. So that can be understood using a basic construction, basic logic is there. See, if suppose I have got this line over here, line segment over here, and I'm making a side over here, any side I'm taking over here. Suppose this is AB, correct? I can do like this. Now what I can do, can I put I've got compass and pencil, with me. I'm putting the needle of the compass at this point. Can I draw an arc like this? Tell me. Can I draw an arc like this? I'm putting the needle of the compass at this point and drawing an arc like this. Okay? Drawing an arc like this. Clear? So basically, are you getting two triangles? One triangle is this. I mean, basically you can join them. So suppose this is C and this is D. You got that logic? So can I not say that this is nothing but equal to this, guys? Because these are same arcs, equal arcs these are, because we have done it using the same compass and pencil, I mean same opening of the compass. So can I take two triangles from here? Tell me. One triangle will be like this, guys. One triangle will be like this, that is ABC over here, and I can take another triangle, it is somewhat like this. Please don't go on the figure, that is not exact, it is just rough. So this is ABD over here. Do you agree with me, guys? Now can I not say that in these two triangles, angle B they are equal or not? Tell me. Angle B they are equal, and you see this was common only. You agree with me? These were common. Hi Abhimanyu. And you see this is equal to this or not, because they were equal arcs. Are these two triangles congruent? Tell me. Are these two triangles congruent? No, they are not congruent. But over here the situation is SSA. The situation is SSA or not. So this verifies that why SSA or ASS is not a congruency criterion. Is this clear to every student in this session? Any doubt in that, guys? Just confirm in the chat quickly. Is this clear? Is it not clear, Kunal? So Ankit, Kunal, Prashant, Abhimanyu, Shinjini, is it clear to every student in this session? Okay. So now let's see one question on the basis of these. Okay, can you do this one? Although this is a proof-based question, I know that you will not be able to do much in the chat, but still you must see this. It is given in this figure that ABC is a right-angled triangle. Okay, right-angled at C. So ABC is a right-angled triangle, right-angled at C. Okay, and it is given that M is the midpoint of hypotenuse AB. M is the midpoint, it means AM is equal to BM. C is joined to M and produced to D such that DM is equal to CM. Correct? That is given in the question itself over here. D is joined to B, that is given. Now we have to prove that CM is equal to half of AB. How can we do this, guys? We have to prove over here that CM is equal to half of AB. Can you tell me how will we do this question? Just tell that, guys. So you see over here, I'm not writing that much. I hope you'll get it obviously. Just suppose I'm writing this angle X and angle Y. In short, I'm writing. So if you see over here, triangle, can I not say that triangle DMB is congruent to triangle CMA? Can I say that, guys? By which congruency criterion are they congruent? Can you tell that? DMB is congruent to CMA. By which congruency criterion are they congruent? Can you tell that? I'm not writing everything. I hope you understand that. So they are congruent by SAS congruency criterion. They are congruent by SAS. The reason being, you see, this is given to be equal to this. This is given to be equal to this. And this angle is equal to this angle, vertically opposite angles. Exactly. So DMB is congruent to CMA by SAS congruency criterion. You see, side, angle, side, side, angle, side by SAS congruency criterion, they are congruent over here. And suppose now if I name this angle 1 and I name this angle 2, so can I say over here that angle 1 is equal to angle 2, guys? Because they are corresponding parts of congruent triangles. Do you agree with me? They are not RHS Kunal over here. I am doing triangle DMB congruent to CMA. So in these two triangles, this is given to be equal to this. You see, it was given DM is equal to CM. And it was also given that M is the midpoint of AB. So therefore, this is equal to this. And also X is equal to Y, because if two straight lines intersect, then vertically opposite angles are equal. Pairs of vertically opposite angles are equal if two straight lines intersect each other, correct? So therefore, DMB and CMA, they are congruent by SAS congruency criterion. And if they are congruent, suppose this is angle 1 and this is angle 2. So 1 is equal to 2 because they are corresponding parts of congruent triangles, correct? And you see over here, if we have proved 1 is equal to 2, what we can say? Can we not say that BD and AC, they are parallel? Can I say over here that DB is parallel to AC? The reason being, these are alternate interior angles and we have proved alternate interior angles to be equal. So I can write over here, alternate interior angles are equal. We have proved them to be equal already over here. Alternate interior angles to be equal, we have proved them, right? So what we can say now, see, these are parallel lines, BD and AC, they are parallel lines over here. So can we not say over here that angle DBC, I can say over here that angle DBC plus angle ACB, that will be equal to 180 degrees or not, tell me? Because co-interior angles in case of parallel lines are supplementary. This is parallel to this, we have proved already. So this becomes a transversal or not, guys? So therefore this angle plus this angle will be 180 degrees because co-interior angles in case of parallel lines are supplementary. Now ACB is already 90, it is given in the question. You see over here, right angle at C. So ACB is already 90. So over here, can I not say that angle DBC plus 90, that is equal to 180 degrees? So from here, can I not say that angle DBC is also 90 degrees? Is this clear to every student in this session up till here? This is one of the important questions in congruency. I hope this is clear. Okay. Now basically, if you see the triangle, we have already proved over here DMB congruent to CMA. We have already proved DMB congruent to CMA. So from here, can I not say that DB is equal to AC by CPCT? Can we say that DB is equal to AC by CPCT as well? We have proved DMB congruent to CMA. So we can say that DB is equal to AC by CPCT. We can easily say that, right? So from here, one more thing we will see. If I talk about triangle DBC, see it, I'm not writing that much, but I hope you will understand. I can say triangle DBC is congruent to ACB. Can I say that, guys? DBC is congruent to ACB. The reason being, understand it properly, because we have proved this angle is equal to this angle to be 90. We have proved DB is equal to AC over here in front of you. And you see over here, BC is common or not? BC is common or not? Tell me. So I can say that DBC and ACB, they are congruent to each other by side, angle, side, side, angle, side. So they are congruent by SAS congruency criterion. So I can say over here easily that DBC is congruent to ACB by SAS congruency criterion. I hope this is clear up till here. And if they are congruent by SAS congruency criterion, can I not say over here that CD is equal to AB by CPCT? CD is equal to AB by CPCT. So I can say over here that CD is equal to AB by CPCT over here. Correct? Now it was already given in the question that CM is equal to DM. So in place of CD, can I write 2cm, guys? In place of CD, can I write 2cm over here? So I can write 2cm, and that is equal to AB. You got that, guys? So 2cm is equal to AB. So what does it mean? Have I proved that cm is equal to AB by 2? And that's what we needed to prove in this question. Is this clear to every student? Kunal, Ankit, Shinjini, Abhimanyu? Is the question clear to every student in this session? So 2 times we have used SAS congruency criterion in this question, and also we have used the properties of parallel lines and transversal. Any doubt in the question, guys? Just confirm in the chat. Okay, so that's all in this question, guys. Let's move on to the next one. Now let's see this congruency criterion. Don't forget that I am not proving these congruency criteria, but there is a proof to these. Only the SAS congruency criterion cannot be proved because that is an axiom. It can be verified, justified practically, but it cannot be proved mathematically because it is an axiom. But all other congruency criteria can be proved. They are theorems. They can be proved. I am not doing that because if I start proving this, constructions and all that is there. So, I mean, only one proof will take 15-20 minutes, right? So, instead of that, we will understand the congruency criterion and then we'll be doing the questions on the basis of them. So, you see, this is ASA congruency rule. You just have to understand the name. That's it. So, ASA congruency rule, if you have got 2 triangles over here, suppose it is ABC over here, and this is PQR, you just have to go on the name. So ASA, if this angle, angle, side and angle, you got that? Angle, you understand the name only. Angle, side, angle. One angle and then a side and then another angle. One angle and then a side and then another angle. They are equal in 2 triangles, then the triangles are congruent. So if over here we have been given that angle B is equal to angle Q, and it is given that BC is equal to QR, and it is given that angle C is equal to angle R, then we can say over here that triangle ABC is congruent to PQR, and you will write the reason in the bracket as ASA congruency criterion. Now many students will say that, sir, we can also write AAS. Many students say that we can also write AAS. See, basically ASA and AAS, they can be proved interchangeably. That is correct. But what you are using in the question, you have to write that congruency criterion only. You see, this situation is angle, side, angle, angle, side, angle. So over here in the reason, if you will write AAS, that is wrong or not? You understand it logically. Over here you cannot write AAS. The reason being, you are using ASA. ASA, you are giving in the reason ASA over here. You cannot write AAS in the reason. That will be wrong. You got that logic or not, guys? So it's a very simple thing over here. So the triangles are congruent by ASA congruency criterion. So therefore you can say over here, okay, and you can say other corresponding sides are equal, corresponding parts are equal. Angle A is equal to angle P, and then you can say AB is equal to PQ and AC is equal to PR. The reason being CPCT, they are corresponding parts of congruent triangles. Is it clear to every student in this session? Ankit, you got the reason? You were asking for SSA, that why SSA or ASS is not a congruency criterion. Was that clear to you? And is this clear that what I am saying, that why you cannot write AAS in this question? If you will write AAS while giving these reasons, it will be wrong, because you are giving the reason as ASA only. So you cannot write in the reason AAS, that will be wrong mathematically. I hope it is clear to every student in this session. Any doubt in this one, guys? Just confirm in the chat. Okay. Now let's do a simple question on the basis of this. In this figure, it is given that AC bisects angle A and angle C. So if AD is given to be 5, can you find what is the value of AB? See, the question is very simple, but when it comes in a proof-based question, you have to give every proper reason. You cannot directly write the answer if it comes as a subjective question in school examinations. So what is the answer over here, guys? What is the answer? So you have to give every proper reason, correct? So it is given that AC is bisecting angle A and C. AC is bisecting angle A and C. It means if I take this angle to be X, this is also X. If I take this angle to be Y, this is also Y. Because AC is bisecting both the angles A and angle C over here. So basically, yeah, the answer is very simple, but when it comes in a subjective examination, you have to give every proper reason or not. Tell me, you have to give that, right? So basically, you can say that triangle ABC is congruent to triangle ADC. The simple logic over here is, can you tell me which congruency rule is being used? Which congruency rule is being used over here? Tell me, guys. So ABC is congruent to ADC over here, but what is the congruency criterion which we will use? I'm asking that. It is not ACD. ABC is congruent to ADC over here, Kunal. You cannot say. Okay, so that is, it is not AAS, Ankit. That would be wrong. You see this situation. This angle is equal to this angle and this side is common. And this angle is equal to this angle. So the reason will be ASA. You cannot write AAS. That will be wrong. You got it? That will be ASA because it is angle, common side, AC is common and then angle. So it is ASA over here. Now if they are equal, you can say that corresponding parts are equal. AB, if they are congruent, you can say that corresponding parts are equal. And you have to give every proper reason. What will be the reason for this? Tell me. Yeah, that is correct over here, Shinjini. What will be the reason for this last statement that AB is equal to AD is equal to 5 centimeter? What will be the reason which you will write in your answer sheet? Tell me. If suppose it comes in your school examination. What will be the reason which you will be giving? Because they are corresponding parts of congruent triangles. So you have to write CPCT over here. If you will not write this statement, suppose it's a 4-mark question or it's a 3-mark question, you will get 2.5. Anybody will deduct half marks for this statement only. No, Shinjini, the last will be CPCT. You have proved ABC and ADC to be congruent by ASA congruency criterion, and then you have to write AD is equal to AB is equal to 5 centimeter. You have to properly mention over there that they are CPCT, they are corresponding parts of congruent triangles. I hope it is clear to every student in this session. Exactly. It has to mandatorily come in your answer sheet, otherwise you will not get full marks. I hope it is clear. Let's move to the next one. So this is side congruency rule. It goes by its name only. If in two triangles corresponding sides are equal, then the triangles are congruent by SSS congruency criterion. So if I am writing over here ABC and I am writing over here PQR, if it is given in these two triangles the corresponding sides to be equal, this is equal to this is equal to this, and this is equal to this. Corresponding sides of two triangles are equal. AB is equal to PQ, BC is equal to QR, and AC is equal to PR. Suppose this is given to you, AC is equal to PR, then the triangles are congruent. Triangle ABC is congruent by PQR. And the reason being what, guys? The reason being SSS congruency criterion. I hope this is clear. Okay, I'll explain that, Abhimanyu. So the triangles will be congruent by SSS congruency criterion, and if they are congruent, corresponding angles will be equal as well. A is equal to P, B is equal to Q, and C is equal to R. Abhimanyu, if two triangles are congruent, then corresponding parts are equal or not. Corresponding parts means what? If you take this triangle and put on this triangle, then corresponding parts means 3 pairs of corresponding sides and 3 pairs of corresponding angles will be equal. So that is the meaning of CPCT. If you have proved these two triangles to be congruent by any congruency criterion, then corresponding parts will be equal, Abhimanyu. Is it clear? Suppose you go by the name. Suppose I have got LMN, triangle LMN, congruent to triangle, suppose XYZ I am taking. So corresponding parts will be equal. Corresponding parts means what? Can I not say that LM will be equal to XY, Abhimanyu? LM is equal to XY. You have to go according to the name only, right? And I can say MN over here is equal to YZ or not. MN is equal to YZ or not over here. In the same manner, LN is equal to XZ or not. LN is equal to XZ. Corresponding sides are equal, and corresponding angles will be equal as well. Angle L will be equal to angle X, angle M is equal to angle Y, angle N is equal to angle Z. You have to work according to the name. I hope this is clear to every student in this session. Any doubt in these congruency criteria up till here which we have done in this session and the questions which we have practiced? Is it clear, guys? Any doubt in that? Okay. So guys, there are many other questions which we will be doing over there. So you see, suppose this question over here, it is given AB is equal to CD and it is given AD is equal to BC. It's a very simple question and we have to prove ADC to be congruent to CBA. How can we prove it, guys? It's a very simple question, one line question although. How can we prove them to be congruent? Can you tell that, guys? So in these two triangles, basically it is given that, you see, AB is equal to CD. It means AB is equal to CD is given. AD is equal to BC is given in the question. And we have to prove that ADC is congruent to CBA. How can we prove it, guys? Tell me. Can I not say that, you see, AC is common or not? Again, I am saying AB is equal to CD. AD is equal to CB or BC, that is given. And the last one is, can I not say that CA is equal to AC? Are they common over here? Are they common over here? Now you would say, why I am writing CA and AC? Because it is working as per the name. You got that logic? See, when you get this triangle ADC, then you will call it CA. And when you are taking this triangle CBA, so basically CA and AC, basically it is the same side, but you are naming differently or not? Tell me. When you talk about these two triangles, you are naming the same side AC, once from here and then once from here. So it is the same thing. Although in this case, if you will write AC is equal to AC, nobody will deduct your marks. In this case, if you will write AC is equal to AC, that does not, nobody is going to deduct your marks for that. I hope it is clear. So therefore, we can say it's a very simple question. Triangle ADC is congruent to triangle CBA by which congruency criterion? all the three corresponding sides are equal by SSS congruency criterion. I hope this is clear to every student. Exactly, Shinjini. AC is common. I hope this is clear. Any doubt in these things, guys, which we have discussed up till here? So actually, there are other questions as well, and one more congruency criterion, that is RHS congruency criterion, which is there in right angle triangles only. So we'll do them in the next session, and we'll be practicing many more questions in the subsequent sessions as well. So that's all we needed to discuss in this session, guys, on the Infinity Learn class 9 and 10 YouTube channel. For grade 9 students, you have got Pratham series. For grade 10 students, you have got Pioneer series. Please don't forget to check the playlist over there, and also don't forget to subscribe to the Telegram channel as well, so that you get updates regarding sessions and questions to practice and the PDFs of these sessions. Bye bye, guys. We'll meet in the next session. Take care, everybody.